that in the scatter diagram, the production is represented in the x-axis, and it is the independent variable, and it is dependent upon the energy or its source consumption, which is depicted in the y-axis, and it is the dependent variable. Okay, so the relationship is established between this energy use and the production, and it is analyzed by the energy auditors. Okay, so it is represented as dots, as it can be seen in the diagram. So in the present diagram, the y-axis shows the steam consumption in tons per month. So this is the steam which is consumed in tons per month, and x-axis represents the production in tons per month. Okay, it can be of some uh, say cement manufacturing plant or steel manufacturing plant. Okay, so here what is the role of the energy auditor? Energy auditor first of all makes few groups, and that group is analyzed. So in the next diagram we will show these groups. So this is the group, this is say 1 2 3 groups, etc. So what is the point of analyzing in these groups? These groups are analyzed for the fact that if there is consumption in steam and production is there, then it is fine. And if there is linear relationship, again it is fine, dependent upon the curve which is it is following, which means that if there is a linear relationship, that if the steam consumption is more and the production is more, then it is good enough, it is not a bothering issue. But if in some cases in the group, if the case is such that despite of the less consumption of the steam, if the production is more, then that is the point of analyzing. As in the case of the uh, first group, you can see that the third dot represent the production of somewhere you can say 1040 or 1030 tons per month, and the energy consumption in the form of the steam is somewhere say around it is again 1030-40 tons per month. So the point of analyzation here is that when the more production can be done at the cost of or at the expense of less steam consumption, then why the second point or the third point, or second point and the first point, is consuming more steam for the less production. Okay, so that conditions are analyzed. Okay, that what is the reason behind it. Okay, so if that reason is analyzed and results are made, so the favorable results are put into the practice for further effective use. For example, you can say that when the steam consumption was more and still the production of the output was less, maybe that steam was having less temperature. Okay, so less temperature, steam was producing less, and even in the less consumption of the steam in the third point in the first group, the production was more. It can be due to the combustible substance combustible substance which is being used. Maybe sometimes you can say that anthracite coal is being used for the production of steam, which is more efficient and it is producing more uh, steam. So more good quality steam at high temperature, so the less steam may also result in the higher production. So this is one of the point of analyzation in the first group. Okay, so these analyzation and its interpretation and its follow-up action can be different from one auditor to other, because every person can think in a different manner, because we are not going to do the live audit. So based on our assumptions, we are going to analyze these groups. Similarly, in the third group, again we can see that there is the linear relationship between the uh, steam consumption and the production, that higher the steam consumption, the higher the production is, that is good enough. But the last point, the curve again dips. So, which means that again the production is more, but the steam consumption is less. So, what is happening at that very point? That is to be analyzed. Again, one more thing is to be analyzed in such cases, that if the input is more, substantially more, and the production is not that very substantial, then it is not good practice to invest more on the input to get the output. Okay, for example, in this third group, you can say, although that the production is increasing, but at what cost? Here we can see that the steam consumption in the lowest most point of the third group, the steam consumption is somewhere around 1350 or 1360, and the production is somewhere around 1250. Okay, that is good enough. But at the last point we can see that the production is 1300 or 1310 tons per minute, per month, but at the expense of somewhere 1820 steam consumption. So what does this signify? What is the interpretation is made by the auditor in such case, that if the production is not having, so here we can see the slope is steep. So if the slope is steep, that is not beneficial for companies. If the tangent theta or the slope is steep, that is not beneficial. Here we can say the tangent angle or the slope is somewhere around tangent 70 degrees, but that is not good. Why? Because if the angle is 30 degree, then we can say that that hypotenuse is more towards the production and less towards the steam consumption. So in that case, what will happen? That the less consumption of steam or the input or any energy resource will result in the greater production of output. That case is favorable. Okay, so this steep tangent is also not a favorable condition. So in the assignment also, I will give one of this example, so that you can do practice and some brainstorming. So in short, we can say that we as a energy auditor or energy auditing students have to analyze this, interpret this, and go for the, or suggest the possible solutions and recommendations for the growth of the company, of which the scatter diagram is being drawn. Okay, so next topic is the benchmarking and the comparative energy performance analysis. Here what we do as a company, or what company do, they try to analyze themselves, that where they stand. So they try to compare themselves to the others. So when they want to compare themselves to others and also to themselves, when we talk of themselves, that means that their current production is to be compared with their performance in the past, and otherwise, in comparison to their competitors or national level or at international level or at the quality standards which they are following, or in the best in the practice, based on those, the plant's performance are benchmarked to various cases. First is the past performance, as I have just discussed, that their own performance or output should not be reduced. Second is the industry average. If the other factories or industries in the market are doing well, so their average should not be below them, and the units of comparison should also be matter. That also matters. Okay, so best in the class, if you are not the best in the industry, at least you should try to be one. You can compare with the one. For example, there are many fan manufacturing company in the India which are working. For example, Usha is there, Bajaj is there, but the say market leader is the Compton Greaves fans. Okay, so their quality is good, their life is good, the material which is used is good. So so the other fan manufacturing companies, what they can do, they can compare themselves with the best in the class. Okay, then the best practices, if the practices during the manufacturing or the quality which is being used, they can compare themselves with that as well. It can be the assembly line process, for example, in the Maruti, or the time gap which they follow, and or it can be based on the ISO standards or the 14,000 standards, environmental standards which are being used. So what are the key steps to the benchmarking? First is the technology process line, which I have just mentioned. Then the metrics that is to be followed. For example, if you are uh, in the production of the energy, so an electrical energy is measured in kilowatt hour. So that kilowatt hour per ton of the consumption of the fuel. So if that is compared, that then it should be uniform for all. It should not happen that sometimes you compare the gigajoules per ton and sometimes you follow kilowatt hour and so on. So that is not good. So then the comparison is to be made and the tracking the performance is to be done. So again, the what we have to safeguard is to compare the apples with the oranges. What does this phrase mean in the benchmarking? That for the local conditions, you can compare one factory with the other, one industry with the other. But if you are comparing the different geographical locations for a particular industries, then that is to be uh, rationalized. Okay, so that there is a justification to that. So what else is to be taken into consideration is the Energy Star program for the industries. As you must have seen, the Energy Star, if you have gone through the previous versions of the Windows, I don't know whether you have a chance to do that or not, but in the earlier versions, earlier Windows 95 was there, Windows 98 was there. So and then later Windows XP was there. Maybe you must have, some of you must have worked on XP, because the Windows 95 and 98, maybe you were just born then. Okay, so that is immaterial, that you must have worked on that. So at that time when we used to switch on the laptop or desktop, the Energy Star logo was reflected in the screen. So that also represent that the environment considerations are taken into the considerations while preparing the product, the hardwares. Okay, so this is the industry program which was initiated by the US Environmental Protection Agency. It is having the short form of EPA, which developed the plant energy performance indicators, EPI, so that the energy auditors and other managers and cooperative executives can evaluate their energy efficiency in the industrial plants for the facilities they have. So it was primarily for the US, but slowly other nations have also developed on the similar lines. And also the similar practice was developed for different industries, different spheres of industries, like potato processing plants, juice processing plants, motor vehicle manufacturing, etc., etc. So to enable to analyze the performance, that where they stand, a benchmarking tool is also available for the cement industry, that is known as BEST. So this is the benchmarking and energy savings tool. So it was developed by Lawrence Berkeley National Laboratory, LBNL, which is into the energy research activities. So this again is developed for different uh, industries, so which identifies this best. So Canadian Industry Program for Energy Conservation has also developed different series. So again, the process was done to also find the cross-cutting technologies, that how can we minimize the usage of energy. So different cross-cutting technologies were developed for motor systems, steam systems, compressed air systems, pumps and fan systems, so that the propellers, impellers, pressure, size of the pipe, etc., could be monitored, leakage could be reduced, and the best possible delivery of the energy can be made. Okay, so here we conclude the unit